screen.
Is there anything else you need, like sound coming in or out?
I think we're okay.
We're good? Okay.
And if I had to go to the terminal for the demo, It's better. So okay, thank you. So do I have to repeat, Jason, for the online audience? Okay, for the online audience, what I just said to the people here in the room, I'll just back up a little bit. We did a quick overview of what we are going to cover in today's session. We will see how to write a basic shell script. I'll tell you how to use variables, how to pass command line arguments to shell scripts. We will see like basic decision making with if-else and also basic for loops. And I'll tell you how to write a Slurm job script. And all of this is going to be really beginner's level. What I told about Linux scripting is if instead of typing commands directly in the shell, if you would like to keep the commands in a file so that you can repeat whatever you're doing multiple times without having to type everything in on the terminal, you could put all such commands in a file and that would become your shell script. Now there are three types of scripts. There are a few types of like shells and hence few types of scripts that one could be using. The three very commonly used one are Bourne shell, C shell, or Conch shell. And for today's session, we will be focusing on Bourne shell. So we are at the point now in the session wherein I would recommend that you open a file. Let's call it myscript.sh using any editor of your choice, either VI or Nano. And once you have the file, you might want to edit and add the content, which is being highlighted with my mouse pointer. So it's hash pound bin sh and echo hello world. These two lines. So when you copy these two lines in the file or maybe type it out, after that just save and quit. And after you have saved the file, we will run it. In order to make a file executable, you have to change permissions. You have to say chmod +x myscript.sh +x again. We give the execute permissions on the file. And for running the script, you would say /myscript.sh. Okay. So I'll leave the content on the screen for a minute for everybody to catch up. So once we are done with this, I'll go do the same demo and show you how it's all working. And if anybody needs help while we're moving from one example to another, just raise your hand. Okay. Okay, now let me show you a quick demo of how this is going to work. So let me restart. So I open this file, myscript.sh. I'll press I to go in insert mode because I'm using VI. Then I'm going to type pound exclamation mark bin sh. That's the first line of my script. And if you're working with bash shell, that's why this tells the shell that it's a Bourne shell script. So, and after that, you would type the command that you want to be inside the script. And in this case, it's echo command. I'm saying echo hello world to the screen and escape :WQ to save the content. So now if I do ls -ltr, you see I have the script created. I have the script created, myscript.sh, but its permissions are read write. If I have to run the script, the first thing I need to do is to grant myself execute permissions. In order to grant execute permissions for myself to run the script, I would use the chmod command. So I would say chmod plus X, and I would type the name of the script, myscript.sh. Now when I do ls minus ltr, you see that I got execute permissions on this one. Okay. So now in order to run this, all we do is // and name of the script. What dot does is it says the script myscript.sh is in the present working directory, and / gives the path further, like // is like at this particular path, go and find the script myscript.sh and run it. There are a few other ways to run the script, but let's just stick with this one particular way of running the script for the time being. So it says hello world on the screen. Is everybody done with this? Wonderful. Okay, let's move forward to the next one. Okay. Comments are very useful, especially when you are working in a collaborative environment, or even for yourself, like should you need to revisit a script later. So in order to put comments in the script, one would use pound character. So you might wonder, like we put a pound in front of the bin sh line, which is on the top, but why is that not a comment? So I do not know. So that's the rule that's there for this scripting guy. So you ought to have like the first line beginning with pound exclamation mark. That's ignored, and that's standard. So first line is always the information about the shell you're using, and it begins with pound. And after the first line, everywhere in the script, wherever pound occurs, that line is treated as a comment. For example, here, wherever this pound in red color is, what I'm saying here is demonstrating how to put a comment. Purpose, print current working directory and its content. So that's all we are having in this comment. You could put any description you want, and should it be a multi-line comment, you would need to put the pound sign in front of every line, at the beginning of every line that's overflowing, to which the content is overflowing from the previous line. So that's how you provide comments. And then let's put a few more commands in the script and say pwd for present working directory and ls for listing the contents of the directory. So should you need to try this out, you could just copy paste if you have the link to the slides, or you could type it out. I'm going to copy paste here. I'm going to create a new script called myscript2.sh. And in here, I'm going to paste the contents of the slide. So here I have, again, hash bang, or exclamation mark is also called as bang in scripting parlance. So hash exclamation mark / bin sh is the first line. Then I provided the comment, right? And then I have pwd ls, 2 commands in there. I save the content of the file, do the same thing. So this will just give you some practice. chmod plus x myscript2.sh. So I changed the permission. Now I should be all set to run the script by typing / myscript2.sh. And you see both the commands ran. First I got the path, this one, printed. This was through the pwd command. And then I got the list of the directories in the present working directory. So this is from, this output is from the ls command that I'm highlighting. Okay. So far so good, right? Let's move forward. So that was our basic hello world kind of program for scripting world. Just like, now coming to the more evolved concepts. Now, just like you can pass variables to a program like a C, C++, or Fortran program, let's say, or you can pass command line arguments, you could do the same thing in scripts as well. And you could define your variables in shell scripts and do some arithmetic or some calculation with those variables. Or you could define some variables, it could be just a string and display the contents of the string. So depending upon what your needs are, you could define various types of variables in a shell script. And the nice thing is, like, you don't have to type qualify. I don't have to say, just like in C, for example, if I were to define a variable that could hold a set of characters, I would say, well, char array notation, and I would provide the length of the string, and then I would create a variable name. It would be like char square brackets inside the square brackets 10, and then I would create a variable name called name, like in this example. However, in the scripting world, if you see, I just provide the name directly, and I'm able to set it to a value using the equal to sign. So in this example, before I even come to this example, let me give you just a quick overview of what different type of variables exist. So there are user-defined variables, and there are some system-defined variables. So system-defined variables are something that's set up by the system by default. And user-defined variables are, just like in this example, we have name, something that you would define. You could use both system-defined variables and the user-defined variables in your scripts, depending upon what you're doing. So some of the system-defined variables are home, path. I'll show you how to use them in the following slide. But in this slide, the example that we have, what it does is, it defines a variable called name, and we are setting the variable to a value. Here I'm setting it to my name, and then I'm echoing it to the screen. I'm saying the name is, and note how I am displaying the content with a dollar. So there's a pound, there's a dollar. I don't know what all other currencies we have in Linux scripting, but you see, we used a $sign to display the variable name. There are few things that you might want to be aware about regarding displaying the values from a user-defined variable. So at some places, you might need things like curly braces. So I'll leave that part for the time being. For the time being, let's just concentrate on copying this and running this, or maybe even typing this and seeing how this all works. So I'm creating a new script. Let's call it myscript3.sh. And in the script, I'm going to copy paste everything. And just to rehash, the first line is standard hash exclamation bin sh. The second line is a comment, and we know that it's a comment because it has pound in front of it. Then I have a variable defined, and this variable is called name, and I'm setting it to a value, RITU. And when I'm setting it to a value, I'm using double quotes. And notice there is no space around equal to sign. So you have to be careful about specifying this line. If you end up putting a space, you can try that out. What happens if you put a space like this or a space elsewhere? So that's something for you to experiment. But in the following line, what we have is, we are just echoing the name that's there in the script. So I'm saying echo the name as $name. So when I'm using a user-defined variable or a system-defined variable, depending upon the context in which I'm using, I'll have to use dollar for sure, and there might be some workarounds for using such variables from certain places in the scripts, and I'll show you an example of that later. But for now, we'll just stick with the simple notation, like $name. That's all we use here. Okay. Now, in order to run this, again, I'll say chmod plus x, and name of the script. And now I'll say name of the script. So you see, I got this message printed on the screen. The name is Ritu. So that's how user-defined variable can be used in terms of like how do how do you define a user-defined variable, how you use it. Okay. Let's do something more. Okay, this is probably a bunch of more echo statements and few other things in here. We have a clear command. Is everybody familiar with clear, what clear would do? If not, you could raise your hand. Thank you. So what clear does is it clears the contents of the screen. So before we go to even the script, just typing clear on the terminal like this. See, everything that was there on the screen just went away, it cleared off. That's what clear does. And let me just quickly give you an overview of some more commands that are there in the script. Let's see what date does. If I type date, it will give me the date of today, today's date, along with the timestamp. If I type another thing, let's say CAL, that's short for calendar, I'll get a display of the calendar of current month. So what we are having in the script, in this example out here, is just a combination of these commands. And I'm just demonstrating how we can use them in multiple ways. Well, let me also show you one more command, WC, before I go ahead and tell you more about the script. So what happens if we do ls? ls is going to list all the contents of the directory, right? Like this. But if I say ls pipe WC word count, and I say -L, it will count the number of lines, or it will give me the count of the number of files or directories in there. Does that look right to you? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. We do have like 13 directories or files in here. So WC -L did give me the correct result when I used it with ls, right? Okay. Now let's go back to the script again. Okay. So first line, it's pretty standard again. Pound exclamation bin sh. Then the first thing we are doing here is clear. We're clearing the contents of the terminal because we're going to be displaying some fancy stuff. So we are saying echo hello $user. Now you might wonder, in the previous example, when I had to use a variable called name, I had to set it to a value before I was able to use it. But that was a user-defined variable, I would say, should you ask me that question. And user, like all in caps, that's a system-defined variable. We don't have to define or set it. Somebody else, maybe the system, if you will, that guy sets this value for you. So what you could do is, before even running the script, should you need to see what user does, like if you type $user. Oh, sorry. I had to say echo $user. It's going to tell me what my username is. So the username for this machine is tax, seminar, and training room. And that's what we displayed out here. Okay. And going back to this example once more. Going back to the script. Okay. So that's what we have in the second line or third line of the script here. Then we have echo today is in double quotes followed by a semicolon. Then I give the date command. Now, okay, I'm not sure if you are already familiar with this, but if you're not, should you need to display run multiple commands on one line, then this semicolon guy is your friend. So like here, one command in this particular line, which I'm highlighting with my mouse, in this particular line, we have two commands, echo and date. So because there are two commands in the same line, I have to separate them with a semicolon. That's what is going on in there. In the following line, what we have is, again, something similar going on. I want to echo the number of files in the directory. And in order to print this message, I put that in a double quoted string like this. and I'm echoing it using the echo command. Then semicolon comes in. What I have there was the command I showed you a minute ago, and that is ls pipe wc minus l. Okay. Then all I'm doing is typing echo calendar is presented below, and I type the command cal. So I can copy paste everything that's here into the script. I can say vi my script 4.sh, and here I can paste the contents of the script that we just went over. Here we say chmod plus x. Oh, what did I do? Sorry. Okay. And then, sorry. I'm running the script now. So you see it cleared the contents, and it's printing the username by saying hello, tag seminar and training room. Today is, it prints the date, and then number of files in the directories are these many, and the calendar and so forth. Are there any questions so far?
Can you put the chmod in the script?
Chmod in the script? Yes, you can. You can. So let's go. So every correct command can put in there. So, but what I have, what you might want to do is have a wrapper script. As in, let me show you. Let's create a dummy script. Let's say vi my script 6. Oh no, let's call it 7.sh, and let's say bin sh, and there I say echo hello world. Okay, so if you say chmod plus x my script, let's see what happens. Something interesting is going to happen now. Okay, if I run this guy, what do you anticipate would happen? So I put the chmod command in the script. Right, because it's not having the execute permission yet. So we can't execute the permission from inside that script. But what we can do is we can take this line from here. I'm going to comment this out. And I'm going to need a wrapper script. Let's call it my script 8.sh. In this wrapper script, I can put this line. And I'm going to show you a dirty way. Notice I didn't put like hash exclamation mark bin sh here, but this would still work. But this is strongly not recommended. I mean, this is not recommended. That's what I should say. So first, I have to set the permission of the script. Now it's an executable. I can now run the script to change the permission of other guy. I mean, let me just show you what the permission on the other files are. So my script 7.sh, this is still with read-write permissions only for myself. So I need to grant it permission execute through this script called my script 8.sh. So should I run my script like this, right? 8.sh. And once this is run, now we have the permissions of this my script.7. Its permissions are execute now. I can now run this. So the long and short of the whole story is, yes, you can put chmod command like any other Linux command inside a script. However, it has to be in a wrapper script, not in the same script which you are creating. So you can't have the script change its own permission, but another one. Okay. So that was interesting question. Thank you. So let's move forward, and if there are any other questions this far, I'll stop and take those. Okay, we'll move forward. There are no questions. Yeah.
How do you get a new line?
I can just put echo quotes. That will just progress the output to a new line. So let's look at passing arguments to scripts. I'm thinking of a nice example, but of a scenario wherein you would want to use it. So let's take an example wherein you want to write a bash script. You're working on, let's say, Stampede, and you want to write a script that does the submission multiple times, like submission of the bad job multiple times. And you want to parameterize the script such that the name of the executable changes every time you do a submission. So that would be one scenario where you could pass parameters to the scripts, like a practical scenario. Now we come to the toy example to see how this whole thing actually works. So in this script that I'm going to show you, all we're going to do is have the user pass two values from the command line, run the script with two values. There could be two numbers or any other thing, like two parts of the name, like first name and the last name. So whatever we are passing from the command line, that's going to go into a particular predefined qualifier. Let's say in this case, it's $1 for the first argument, $2 for the second argument that we passed from the command line. So that's what we are going to be doing. So let me also mention one important thing here. So the special variables or qualifiers, whatever you want to call them, $1 to $9, including actually $0, they have some well-defined meaning. As in, if you don't specify what the first argument or the second argument is, you just directly use $1 and $2, you should be all set. I must have not made much sense. Let me just show this, how it all works. So my script 8.sh. Oh, I have something with that name already. Okay. So here you see in this script, I'm not defining any variable inside the script, but I'm using $sign. That means I ought to get the value from somewhere, and this value is going to come from the command line. And in Bash world, if you use anything between $0 to $9 or $1 to $9, that means you're going to be passing those many arguments. If you need to use, let's say, if you need to pass more than 10 arguments on the command line, there are ways to handle that, and I'll show you how to do that. But for now, let's assume that in this script, we want to pass just two values from the command line, and therefore we have $1 and $2. So in order to use the script, let me say chmod plus x, this one, and I run it. Okay, first let's do it the wrong way. I'm not passing any arguments. I just run it like we were doing earlier. See, I get a message saying the name entered is nothing. So $1 and $2 was not set to anything yet. But if I pass, let's say, my name, and if I run the script again, so what it did was, whatever the first value after spaces, the first name, it takes that as $1 and prints it. And whatever the next value is there on the command line after the space, after the first argument, that's the second argument, and it displays that. You can run it with something else as well. Let's type a number there, 23. So it will say the name is 23. So it doesn't understand much what's the thing that you want to be printing, as in you could be printing number and calling them names, but all I'm trying to demonstrate is how to pass values, be it string value or be it number, from the command line. And again, you noticed, just to rehash, $1 to $9 is reserved for usage like directly. But if I put, let's try something now in the script. I'm not able to articulate this well. For some reason, I'm having a shortfall of words at the moment. So let's type. Let's assume that we're going to pass 12 arguments from the command line, and just like I had $1 and $2, let me try something like $12. Now this is going to be insanely long command line. I'm going to be typing like 12, 13 values in here. So let's say 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I just gave more than it needed. Oh, what happened? Maybe I forgot to set the permissions on this one. So chmod plus x my script 9.sh. Okay, now let's run it again with this long list. It's going back. Nothing is happening, right? And do you know why? Because I used 12. Like I was telling you earlier, for 1 to 9 or 0 to 9, you're good when you want to be using it directly in your script. I mean, those many parameters. But if it's like beyond a particular number, like beyond 9, you might be required to do a trick. Something like this. Let's see if this will work. I do not know if it would work, but let's try. No, that didn't work, right? So, yeah.
Sorry, when you're trying to execute that script, you're actually
Oh, sorry. Thank you. No wonder it kept on going back like that. So, you see, now it worked. Let me create a bad example again. Let me go back to this example again, and let me just remove this curly brace from here. Thank you so much. Let me just remove this curly brace from here. Okay, let me run this now. You see, I got something interesting here. So I was expecting the 12th argument, which is like 1, 2, 7, 8, 9, 10, 11, 12, right? But what did I get, like 22? In order to set this right, what I would need to do is use the trick of curly brace. If I put a curly brace there, it would work as expected. Okay, so that's a trick that I was telling you about earlier, using curly braces along with $sign to print the values from the script. I have no idea.
No, it's because your first one is $1 that brings that up to 2, and then the second 2 will be 5 arithmetic. That's why you get 22.
Say that again, see?
So you get 22 because that's $1. You put dollar there, and then $1 will just be passed into the fourth argument you put that in. That is a 2. And then the following is just the 2 you put in item left.
Oh, okay. Okay, that's nice. That's interesting. But if you need to get the right value, it's the curly brace that you use. And there's one more trick you could use, and that is, well, let me just do this. Well, this is the simplest one. Let me just leave it at this. But You could use, should you not want to, should you work, let's go to a for loop. When we go to a for loop, I'll show you how to deal with n number of arguments in a loop without having to use a number like this and use the trick of curly braces. So we're,
Is it reading those input arguments as strings or as integers?
so it depends upon what you're doing. If you're doing something, the next example will clarify this, though I think it's the next example. If you use something for calculation, we need something like an eval or expr kind of extra function to do some mathematical work. If it's not like a mathematical work that you want to do, you can just print it directly like a string. So it totally depends upon how you, just like in C, you would have to do something like A to I for converting strings to integer values, should you need to use the input as integers, or A to F or likewise. So here the fix is to use eval or expr or some evaluation mechanism. Okay. Okay, so let's go to, this has stopped working for some reason. Jason? I have no idea why this has stopped working. I'm not able to go to the next slide. Oh, it started working. It worked. So all it needed was to come here. Thank you.
Oh,
Yeah, it's working now.
Okay.
Thank you. You don't have the link yet? Okay. So let's do some arithmetic, just like our friend here asked. Should we want to pass the numbers, should we need to use the numbers passed from command line as like values to an expression? This example shows you how to do that. So you have pound, exclamation mark, bin, sh, just like other scripts. But here we are having a user-defined variable called sum. And note that after equal to sign, I have a backtick or a back quote. So this back quote is used to provide an arithmetic expression for evaluation. So what you have here is expr, and that's another command. And what this expr is going to do is take the arguments, argument number 1 and argument number 2 passed from the command line, and it's going to add them up and print them to the screen. So here we have so let me just copy this and we'll do a demo of this one as well. My script. Okay, so let me just do a chmod. I made a syntax error, and let me see what I did. Maybe while copying and pasting, I inadvertently did a mistake. Let me just. Oh, I'm getting a syntax error here. Sum equal to expr $1 plus $2. That is supposed to work. I must have made an error somewhere, a tiny one. Let me just copy this individually. In order to troubleshoot this. Okay, if I do this, I have no idea what error I'm making. It looks right to me, like there's a backtick. Let me try it on another place. Okay, let me. Yeah.
I think it's because you aren't entering the arguments.
Okay.
I think it's because you're not entering the arguments, the numbers.
Oh, that's right. Oh. And it's giving syntax error because of that. If I do it just like arguments. Let me just look at this one more time. So let me just remove this. Run this again. Yes, you were right. Thank you. Yes. So script was right. The way I was using was stupid. So, but I still don't know why it would say syntax error. So that's like how to do expressions and evaluation of numbers or command line arguments. Okay, now let's do some conditionals. So whenever you have to do decision making in scripts, you would use conditionals like if else or switch case. And the example in the example that we are going to do now is just for if else. Just like in C programming or C++ programming, you could have various versions of if else, like if else, or if else if else, or if else if else. So there are basically like three ways, depending upon how many levels of decision making you're wanting to make. You could have that many levels of branching. So in the example that we have here, we have just two levels of branching. We have if else, if then else only. So in this script, what I'm doing is I'm having hash exclamation mark bin sh and if minus t $1. So all I'm saying is like, if the argument that's passed in the command line, if it's a directory, minus t helps me do the checking for that. So if it's a file, I would do minus f, just in case you were wondering about the syntax. So if I want to say, if I want to check, like if it's a directory that's getting passed or not, so I will have a check like this, and the condition that I'm checking that goes inside square brackets, and I have a then clause here. So I have if whatever the condition we need to evaluate, it goes there, then. And what is it that you want to do if this evaluates to true? If this evaluates to true, I want to say ls $1. Whatever the path of the directory that was passed, that is $1 in this case. So just list the contents of this directory. In the else part, all I'm doing is listing the contents of the file. So I know that if it's not in Linux world, if you were here on January 28, I told you, everything is either a file or a process. If it's not a file, I mean, even directories are treated as files. So if it's not a if something that you are passing, its type is not a directory, it has to be a file or a process. But we don't have paths to processes, right? So it has to be a directory or a file. So that's what is going on in here. Simple logic. I'm just going to copy paste this in the script here. So you see in here, when I ran this, I did not pass an argument. So it took dot, it automatically, like the present working directory, it got nothing in, it got all the files that were there in the directory and it just printed it. Now, to be more specific and correct, I will take this whole path and I'll pass it to this. I should get the same result if I pass the whole part to the script. See, I got the same result. But now if I pass a file name instead of a directory name, I should get the contents printed. You see, because I had a cat command, I got the contents of this file named myscript4.sh printed on the screen. Looks fine. Should you need to wait? I mean, in case you want me to wait while you're trying this, let me know. Like, is everybody wanting to try it out? Okay, I'll bring the. If anybody needs help, just raise your hand. In case.
When you could go back to the sum,
Yeah. Okay, so hopefully everybody is done with the if else part, but if not, or if anybody else needs help. Okay, that's great. So let's go to loops. So loops can be written in few ways in scripting. So you could use for or while. You could do this. I mean, you could do nested for loops, while loops, etc. Everything in here. So here, in the first example that I'm showing you, it's a very simple for loop. All it is doing is for I in ls, do echo $I done. So what this means is for n number of iterations where n is figured out by this expression. And the expression that's controlling the number of iterations of the for loop again, or the condition, is the highlighted text. So when we do ls, we get, let's say, 10 lines. So for each element in the content, like for each line from the ls command, that's the number of times that we want to be running the for loop. So let me copy paste this. vi my script 12.sh. So here I'm saying for I use my loop variable in ls, where ls depends upon how many directories or files I have, I'll get in ls. So depending upon how many files and directories I get using ls command, that's the number of times for loop will run, and that's the range of values that I will take. And I'm saying do. So after the condition is provided, we have a semicolon, and then I'm saying do, and do what? Echo $I. Just do echo $I n number of times, where n is however number of files or directories there are that we get with the ls command. And then done. So basically the syntax, the bare bones syntax would be, let me just get rid of this echo. Condition. So this is how a bare bones for loop would look like. For whatever condition is that you want to specify, semicolon, then do, and then you provide the steps that you want to do in a loop, and after that, done. That's how you close the for statement. Okay. So, oops, I didn't show you the example. Let's do this example at one time. So if I do ls wc minus l, oops. So there are 20 files and directories I have in this path. So I'm expecting this for loop that we have in this script to run 20 times. So let me set the permissions correctly on this one. And it echoed it ran as many number of times there were the files or directories, and it echoed them to the screen. That's what the script did. Now, if instead, what I could also do is, if I have to see, I'm just seeing, just to simplify the script. So if I run the script, what I would see is like hello, n number of times, where n is equal to the number of files or directories in the current working directory, right? Because I said echo hello. If I say echo $1, the name of the file or directory that will get printed. So the whole point of this demonstration that I did with hello and $I was to show the number of times this for loop will run and what is it going to print. So here, because I use $I, I'll get whatever I is, the name of the directory or file printed on the screen. So that's about for loop, a very simple one. You could nest the for loops. So here I have an outer loop, which the outer for loop runs from 0 to 2. So it should run maybe it should run 3 times. Then I have like do, and notice this syntax is slightly different from the one that we saw at the top. The upper for loop, there were no round brackets, but here when I'm providing this expression, arithmetic expression, the for init condition, for stop condition, the stride, for this kind of for loop, I needed 2 round brackets, and then that's just the syntax, and then the do, just like in the previous loop, and then done. This one will comprise of the outer for loop. Whatever we do inside here, let's see what what we're doing in this inner loop. So in this inner loop, we have run controlled by jth variable, and it's running from J0 to 4. So whatever the contents there are, they should be printed 5 times. And I have echo hello test, whatever the value of I is and whatever the value of J is, that's what I'm printing on the screen. Then I've done, then I'm just printing a new line. So we will see what happens if we don't have this line, echo and empty strings. We will experiment with that. So the whole point of echo and code says, after one iteration of the outer loop, I should get a line, and then the next iteration should begin. So that's what is going on in here in the script. So let me just go here. Okay, I have something there. Okay. So first, let's get rid of the echo. And let me change the permissions in here. Oops. My script 13, I must have made a typo again. Oh, yes. Okay, so here I get the values of I and j as they vary through the loop, but everything is like all together as one block. If I need to put spaces between the output from each iteration of the loop, just like Dean was asking a few minutes ago, I just need this guy, echo and quotes with nothing inside them. That will print an empty line. Now when I run this, you see, so the top group of statements is from the first iteration of the for loop, then the next group is from the next iteration of the for loop, and so forth. So when i's value is 0, j ran from 0 to 4. When i's value is 1, j ran from 0 to 4 again. When I becomes 2, j ran from 0 to 4 again. So that's pretty much what the script does. So I'll leave this example up for you to try. And I'll go around. And I think our friend here has...
So. So, this one.
And also your
Let's see who's there in the script. So we do cat on that. Oh, for I in this, it's backticks. So instead of the single quote, it's this guy. That's
Okay.
good enough.
No, I can't copy this.
Oh, this I want to make sure so what for copying. May I show you?
Yeah, go ahead. See if it'll work.
Oh,
I don't have a mouse.
oh, okay. Oh, this is. I'm
Yes.
sorry.
Yeah.
But maybe you discovered the same thing that our friend here discovered with the syntax. So, maybe you want to check it out?
Yes.
Did you
that's what I'm
discover?
trying here.
This one?
Yeah, that one I did discover.
Oh, it is quite the same. So let's move forward and let's do the first exercise. So in this exercise, if you're already familiar with MD5, what MD5 does, you could raise your hand. Or if you don't know, then I'll know. Do you know MD5? Okay, then let me tell you. What MD5 does is it gets the checksums of the files for you. Now think about it, why checksums are important. It's a tangential topic to Linux scripting, but still, let me just spend a minute on that. So if you're doing quality control or doing data transfers, and you want to make sure that the data at the source and destination is exactly correct, the way it was shipped at one end and the way it was received, one trick to do that is to check the checksum value. So checksums are unique hash codes, if you will. So each file will produce a checksum. So if two files are same, they will have the exact checksum value. But even if there's a space here or there or a semicolon here or there, the checksums would change. So that tells people that the data is the data has changed during transfers or for other purposes. Also, like in general data quality control, they use checksums. So there are a bunch of ways to find checksums of the file. MD5 is one trick or one method. Other is SHA-1. So let me just go to the Linux prompt here and type, let me get a file name, MD5, and I'm going to say my script 13.sh. So it will print the checksum like this with MD5 in caps, the name of file that I want to find the checksum of, and then it will give the checksum value. So like I was telling you, MD5 is one checksum utility, other is SHA-1. So SHA-1 and MD5 vary slightly in the algorithm they use to calculate the checksums. But if you do SHA-1, SHA-1, that will give you the checksum of file as well. Oh, SHA-1 is not available on this terminal. So, but on Linux, on Stampede, let's say if you work on Stampede, SHA-1 is available on Stampede. So here, I think MD5 is available. So you could just do MD5. So MD5 should be available by default everywhere. So in this script, what we are trying to do, or I made a mistake. SHA-1 is there? Some, okay. No, SHA-1 would have worked too. Yeah, I have no idea. It's not available here, but you could try this out on Stampede. It's available there. SHA-1. Okay, so now coming back to this one. So your exercise is, you want to write a script that finds the checksum of a file whose name is provided as input. Just like one of the scripts we had previously, we were passing the name of the directory from command line. So here in this script, what you would do is pass the name of a file. Note that MD5 will give errors if you give it a directory name. You can't find a checksum on a directory. You have to the checksum at the file level with MD5. So your script should be like maybe just 2 or 3 line script, I anticipate, and all it would do is grab the input passed from the command line and use that to print the MD5 checksum value. And
See, if you have one.
So, then we got not start to be
Oh. Oh, nice. So probably that's what our friend needs there too. Thank you for figuring out. So that's the problem of the way the paths are recognized in the system. It's not a problem of the script. So all you need is wherever you are, where our friend within our there, if you type source and type the name of the script, that will give you the problem. Enter. So the problem is it was not the script per se, but the path where the path was randomly recognized in the system. So is it your own installation of Linux? Which version did you install? So I'm not sure why it would recognize your current path. But it will be able to run other scripts. I did not know why. You have the same problem? Yeah. Thank you. I owe you a candy. So the for loops, like they would throw error if you run it with dot slash. So if you source the file, it runs fine. It's a one. Are you also looking at 1 to 5? So it's in a 1 to 3. Oh. Yeah, I've been with it. Some people know every 5 years with a phone. Okay, so people, if you are using a version of Linux that does not have MD5 or SHA-1, then you could try MD5 sum, one word, or SHA-1 sum, all one word. Not sure what version of Linux you're using or what all it supports, but you could try a few things like that. MD5 or MD5 sum, SHA-1 or SHA-1 sum. All of them are open.
So it seems like majority of you are done with this one. If not, you could raise your hands. Okay, let's move to the next exercise. In the next exercise, instead of finding the MD5 checksum value of just one file, you might want to try finding the checksum value of all the files in a given directory. So what that tells you is if you have to loop over the contents of a directory one by one and treat them as your argument. So if it's like a file, then you will find the checksum. If it's not a file, you will not do an MD5 checksum on that. And again, just in case like you haven't used the syntax earlier, I'll bring this slide up, which had the syntax for an if condition, wherein we're checking for directory. So here we're checking for a directory. But if it's a file, you would want to do a check on -f. So -f for file, -d for directory. So what you want to do is, if it's a directory, do not do the checksum. But if it's a file, only then do a checksum. And you want to be able to take a path to directory path as input and iterate through all the files in there. Is everyone done with the exercise? If you're done, could you please raise your hand so that I get a sense of the idea? Wonderful. Maybe half people are still doing it. So if you try to get a division that, what happens is sharper, like fixed sharper and right. That it is unable to do. So the fixed circle is going to go up and then you will say $1 slash, because we want to iterate through all the files. This is not that shallow. Okay, I think it's, I will stop this now. Now we feel slash, and then they will put five. Yeah, let's get this back in here. The problem was here. Yeah, the batch. That's right. And the other thing, the only other thing that did was give a space here. Space between the closing bracket and the yes. Oh, you satisfied that here. Oh, gosh, thank you. That's what we want.
Reggie, if you executed that script that's in the slider with no parameters, no arguments, what would you expect it to do?
Depending upon the shell you are in, if it's a very kind shell, it will say argument missing. And if it's not a kind shell, it might say error, or it might just not print anything. So depending upon what exactly is the error.
What I'm seeing on the shell that runs in topics is that it calls through to does the LS. No parameters. It does the then, even though
You don't give the directive.
so I didn't give it a directive.
It will take the correct one. It will automatically take the correct one.
It would be the thing.
Okay.
No, see, I'm looking at $1, that's the original $1.
It will take the default directory as $1.
Oh, okay. It will take current location. Even though I just.
Yeah.
It works.
Yeah, exactly. Okay. So pretty much we have covered now loops, conditionals, and a lot of you are already done with the exercises. So let me just quickly run to the next part. And just a disclaimer, whatever will be presented after this point is essentially true for Stampede or TAC resources. So I'm going to tell, because we got requests from people who want to learn how to submit jobs on Stampede. So I'm going to show how to write a script to submit jobs on Stampede. So should this not be of interest to you, I would be deeply sorry for that. So first thing I want to tell about connecting to Stampede is, assuming that you are working on a Windows machine, then you need a client like PuTTY or SSH, a secure shell client, or some other SSH client like OpenSSH to make a connection from your Windows machine to a Linux supercomputer like Stampede. So if you are on a Mac system though, all you need is to go to the terminal. So does anybody have a question like how to do SSH to a remote Linux machine, or how to use SSH secure shell client to connect to a remote machine? We're all good on that? Okay, wonderful. So this diagram is one I'm very proud of because it took me not 1 hour, but maybe 2 hours to get it right with all the formatting and everything. So what I'm trying to show here is the overall view of what happens when you're trying to connect to Stampede to submit a job. So you would come to Stampede via an SSH connection, and the place where you end up at the beginning is a login node. And once you're at a login node, that's the place from where you would submit your job to run on a compute node. So on Stampede, we have a variety of compute nodes, and each node has its own special characteristics. I mean, different types of nodes have their own characteristic features. For example, we have large memory nodes which have like about a terabyte of memory on them. We have visualization nodes which are equipped with GPUs. Then we have the compute nodes in the normal queue, which are equipped with a mic card. I mean, all our compute nodes are equipped with mic cards, but if you go to, let's say, normal 2 mic or normal mic 2, those nodes are equipped with 2 mic cards. So forth, depending upon the queue that you want to be running in, you have to make an explicit selection of that at runtime. Like, I want to submit my job on a compute node from this particular queue. And you might want to be aware about the different file systems that that you're working from. So on Stampede, there are 3 file systems: home, work, and scratch. So this is how it ties into the current session. So today I told you about system-defined variables and some user-defined variables. So on Stampede, let's say when you log in, the place where you are on a login node, and it's the home file system that's mounted there. And if you type $home, like all in caps, home, it will give you the present working directory of your home, where you are. So that's about like submitting, or how do you connect to Stampede to submit jobs. Then I'll just skip this part because majority of you know how to connect to a remote Linux system, seems like. So I'm quickly going to go to the user environment. So when I have logged into Stampede, like I'm going to do now, and I'm on a login node, missed this. Stampede, okay. So I'm on a login node on Stampede now. And if I do this, echo home, it will give me whatever the content of the variable home are, and home is set to my current working directory in home. So that's what I get there. And if I want to see the username associated, I'll get my username associated with the account. Okay. So there is a notion of module system if you work on a remote computer, if you work on a resource like Stampede. So modules help you manage the user environments. On Stampede 2, we have a module system which help you manage the software dependencies between different packages. So for example, if you want to, let's say, use HDF5 or NetCDF, or let's say FFTW3, any of the libraries, what we have done is all the software that's dependent upon on FFT, I mean, all the software packages on which FFTW3 depends upon for it to run correctly, we have built those dependencies in the environment. And when you do like a module load for FFTW3, it will set your library path and everything correctly. So that's the advantage of modules, that it gives you some flexibility to manage your library paths, etc. So module is what I'm going to tell you. Modules is what I'm going to tell you more about. So if I type, so the commands, there are a bunch of commands to see what all modules are available or what all software packages are available and on Stampede. And there are some packages that will be available by default in your directory. So the command to check that is module list. So if I do module list, I'll see all the packages which are by default in my home. But if I want to see what other modules are available, I'll say module avail. That's a command I will use. So for example, Elemental, RStat, FFTW2, FFTW3, I'll get a list of all the packages that are available there. So, Shruti. What is going wrong? Okay. So that was about the module, quick 2-3 module commands. And should you need to load a particular module, I would just say module load and name of the module. Let's say I need FFTW3. That's module. I made a mistake in the type, in the name here, module. So it will load the module in my environment. Now, if I do module list or ML for short, I will see that FFTW3 gets loaded in my current location. So I want to, let's say, look at what happened to my library path. I'll say echo LD library path. So this shows me that the path to the FFTW3 library that got appended to my list of library paths. Now, if I want to see what other, depending upon if there are other dependencies that so FFTW3 is dependent upon and you need more libraries. So this is a place where you would go and check what all got appended to your library path. Okay, so that was a quick heads up about module system. Which is going to help, which helps us to manage user environments. And I'm going to quickly go to, there are a bunch of other module commands that I'm not going over. I have just 4 minutes. So in this 4 minutes, I'll just quickly show how to write a script to submit the job to Stampede. So in Stampede, the job scheduler and the manager that we have is Slurm. So Slurm has got a bunch of options. So you specify the options, the Slurm options that you need to run your job inside a script. Just like you have been writing hello world type of scripts, this is just another script. But all it has is the specific options that are specified using #s batch. So all the lines which have like #s batch in them, I'm using them to specify the options for the job scheduler. And then I specify like an echo command. If I do set -x, I'll be able to get a copy of all the commands in the script from this point forward. So I want to run a job in parallel, let's say, and the name of the executable is example1. So on Stampede, if you're familiar with Stampede, we have wrappers for MPI libraries. So I mean, the way you would run an MPI executable elsewhere, you would say MPI exec or MPI exec.hydra, for example, or MPI run, for example. But the tag wrapper for the run command is IB run. So this is specific to tag resources. So this might not work on other resources except probably Comet or Gordon. One of the STSC resources is where you can use this IB run command as well. But pretty much everywhere else you need MPI run or something like that. So in this script, I'm specifying how do I want to run my job. So the first line, of course, is bin bash. We were doing bin sh till so far. So here I'm saying specifically bin bash, and then I specify the job name. When my job runs, I want my MPI, this name associated with it. Then I want to specify an output file and error file. So output file is specified with the -o option, and the error file is specified with the -e option. Whatever I do here, I could give any names for the output file and error files. What I'm doing here is I'm taking the job ID with %j. In Slurm parlance, like this is typically Slurm, %j is defined to give you the job ID. So what will happen is when you submit the job, whatever the ID is, let's say 1234, it gets appended to after .o here. So you will get a file created with the name mympi.o and a particular job name. So likewise, you'll get an error file created too, should you need it. And I'm specifying here the number of cores I need to run my job on. So here I specify that with lowercase n. And then I specify the queue in which I want to run the job in. As I was telling you, we have a bunch of queues on Stampede. And here I'm picking the normal queue to run this job in. More information about the type of queues and their limitations is available in the Stampede user guide. And I recommend going there to learn more about that. And then I'm specifying the time it would take to run this with a -t flag. And then I'm specifying the account to use to run the job. So we work as per, each account is associated with an allocation on Stampede if you're working. So the type of, one person can have like 2 or 3 or 4, maybe even 20 accounts to use, to build their SUs to. So the account here that I'm using is named as ACCSC, and the option I used is -A to specify that. So that's pretty much all about Slurm job script. So if I have to give you a demo of how to run this, I can take this like this. Oops, sorry. Come on. Okay. Is it file or directory? Okay, so I have this script already available here. So that's what I showed you. Here I removed the line for the error file. If I don't provide a separate line or separate option for error files, all my output is going to go in one file, and that is what is specified with -O. And here I need to change the allocation number. So I'm going to edit this and say C, and then echo commands, and I'm going to run this example. So that's my job script that's prepared. In order to run this, I need the sbatch command. So I'll type sbatch, that's a Slurm command to submit a job, and I'll provide the name of the script. And if I have not made any mistake or any typos, like I've been making a lot, this should go smoothly. So my job got submitted, and I'll get assigned a job number. In this case, it's 6544679. So let me see what is going on with the job. So I got a file generated, mympi.o, and this job ID that we got by submitting the job that gets appended to the name there. So that's what I wanted to show you. And in order to check the status of your job in the queue, you would run sq command, sq-u, the name of the user. So this tells me that my job is running because the status of the job is R, and it's running on 2 nodes, and these are the node numbers it gives. And it's an MPI job, which was a pretty simple, like hello world kind of job. So let me just show you what I would have in here. So I got a bunch of errors because I didn't have a file with that name in my current directory. But you get the idea, right? So let me see if I can compile this, mpicc -o, my example. My example. Oh, no wonder. This is the name. Seems like Robert is experimenting. One of my colleagues is experimenting with something, and that's giving those errors that you just saw. So let me just go to my job with sh. I'll use the same executable name that I just created. And I'll do an batch again. So while this job is getting submitted, if you have any questions regarding submitting jobs on Stampede or using it for your purposes, you may ask them now. And for the online audience, thank you so much for your attendance. And this brings us to an end of the session. It's waiting in the queue. So anyways, while this is waiting, if you have any questions, I'll take them now. No questions? Thank you for coming. So yeah, my job ran, just in case if you want to see what got in there. So see, I got this message printed, wonderful class, a number of times in here. That's it. So you can stop the broadcast.